For decades, the world moved in black and white. Cities grew, engines roared, but the planet paid the price. Now, the world is changing. And we must change with it.
Last year, we took this turn. We moved beyond hydrogen, exploring what lies beyond. Because innovation isn't black or white, it's full of color.
This year, we build upon the knowledge from last year. A small, powerful engine designed for fuel flexibility. Affordable green fuels for everybody, always and everywhere.
The future won't be powered by one idea. It will be powered by all of them, working together. We, as a student team, can push the limits, learn and adapt.
Innovation happens in the colors, in the contrast where ideas collide and new ones are born.
Good evening, everyone, and welcome to the design presentation of Eco-Runner 16. My name is Luna ten Hage, and I am this year's team manager. And tonight we are really proud to take you behind the scenes on what we've been working on for the past months. The design of our brand new vehicle. A design shaped by the insights, creativity, and endless hours of work from all of my 26 team members. And during tonight's presentation, different team members will walk you through the key decisions and engineering choices they've made to come to this newest design. But before we reveal this to you, I would like to take a step back and zoom out. Away from here, away from Delft, to take a broader look at our planet. Then we see that there is a lot happening right now all around us. So much that you would almost forget that we live in a climate emergency, because that is what the European Parliament declared this situation, a climate emergency. We've seen that over the past decades, the global temperature has risen dramatically. And here in the Netherlands, the temperature has increased by 2.3 degrees since the end of the 19th century. And we are directly facing the consequences of this warming. We see that extreme and unpredictable weather is becoming the norm rather than the exception. We see devastating floods in Spain that have destroyed homes. We see wildfires in Greece that have damaged the ecosystem. And we see countless animal and plant species that are dying out. And as a result, hundreds of people have lost their lives. This is no longer a distant future scenario, but a reality we now face every day. Don't you find it frightening to see how all over the world we are pushing the limits of our planet? So, the science is clear, and to prevent worst impacts of the climate change, we must take action. Right now, if everyone lives like we do here in the Netherlands, we would need the resources of 3.6 Earths to sustain our lifestyles. I can imagine that this alarmingly high number can make you feel overwhelmed. For me, it does, since I am part of the generation that will live with the long-lasting consequences of this warming. For me, this number makes one thing very clear. Our current average lifestyle is not sustainable. And it makes for me another fact equally clear. Currently, this climate emergency is a race we are losing. But I believe that it is a race we can actually win. But how are we going to achieve this? Well, one major part of the answer lies in the transportation sector. Since this sector is in the European Union the largest source of global greenhouse gas emissions, covering roughly a quarter. With mobility from land, air and sea pumping out more than 8 billion metric tons of carbon dioxide equivalent into the atmosphere every year. This alarmingly high number really shows how much room for improvement this sector holds. And to reduce the emissions, we must rethink on how we move. But more importantly, how we power that movement. Now we are using a lot of fossil fuels, and transitioning from these fossil fuels to a more greener solution is one of the biggest steps we can take here. But the next question is, how can we end our reliance on fossil fuels? Well, to achieve this, one major part lies in using renewable energy. These options are all around us. We see wind, water, sunlight, and organic waste, and these are all options that can provide energy with little to no greenhouse gas emissions. Take, for example, bioethanol. This is a biofuel that can be produced out of a range of biological materials, such as sugarcane or starch-rich materials. These options are everywhere, and many more are coming. But to come back on the question on how we can end our reliance on fossil fuels, we see that the answer is not that simple. We at Eco-Runner see that the answer consists of a complex system made out of 5 key pillars: technology, infrastructure, planning, policy, and behavior change. And integrating, combining, and balancing these 5 key pillars will reduce emissions. Our focus at Eco-Runner lies in the pillar of technology, demonstrating the potential of innovative solutions. And this journey goes already back for more than 20 years, to 2005. In that year, a group of 11 enthusiastic students came together with one shared dream: to build an efficient car. And in that year, the Eco-Runner Foundation was laid. Over the years, multiple teams took over to further advance technology, teamwork, and innovation to new levels. All the teams wanted to create the most efficient cars, meaning that you can drive the longest distance on the least amount of fuel. And we wanted to drive on a sustainable fuel. Back in the day, the focus was on hydrogen as a fuel. All the teams wanted to give answer to the bold question, can Eco-Runner push their limits to create the most efficient hydrogen-powered cars in the world? Well, yes, they could. And the evidence, they competed in international competitions, won these competitions, set Guinness World Records for the most efficient hydrogen-powered cars, and built the first street-legal hydrogen-powered cars built by students. For more than 20 years, Eco-Runner has been at the forefront of innovation, showing the power of hydrogen here. But since we want to remain at the forefront of innovation, and we showed the power of hydrogen, last year the Eco-Runner 15 team decided to switch lanes. They wanted to explore an alternative sustainable fuel. And in that year, the Eco-Runner focus shifted towards fuel flexibility. Because we now, as the 16 team, believe that there is not one perfect fuel. Not one solution, not a black or white answer. We believe that the future of mobility is a spectrum of colors. A multi-fuel future, where different clean energy sources work together and side by side, each fitting the needs of different regions and challenges. Because we believe that creating a sustainable future of mobility means embracing flexibility. And that is exactly why the Eco-Runner focus shifted towards fuel flexibility. We are now developing a vehicle that can drive on a range of multiple solutions, where not only hydrogen is a solution, but many more. And to achieve this inside our city car, we are using the technology of a micro gas turbine. This year, we will ensure a full integration of this micro gas turbine and prove that our Eco-Runner 16 can drive on multiple sustainable fuels. And to prove this to the world, we will, at the end of our year, drive with the Eco 16 at Zandvoort Circuit. Now, you might be wondering, what does this fuel flexibility look like on 4 wheels? Well, since August, my team has been working really hard to create this final design, and it is now finally time to share this design with you. My engineers will explain in detail the technology behind this micro gas turbine, and in addition, we will explain why we need to be flexible to contribute to a sustainable future. And with this fuel-flexible mindset, we continue to innovate, to prove that a sustainable future of mobility isn't just a dream, but a reality we are building right here together.
20 years ago, we began pioneering hydrogen cars.
We broke records and proved what is possible.
But progress doesn't stop, it evolves.
The cycle of innovation starts again.
The world is changing, and so must the way we move.
Solutions exist, but change is too slow.
That's why we take action.
Designing, testing and building a new kind of vehicle.
We take bold steps.
We experiment, test and learn fast.
Progress only comes when you dare to try.
This year, we further explore the micro gas turbine.
A compact, powerful and flexible engine.
Running on multiple sustainable fuels.
Built for performance, moving towards efficiency.
In uncertain times, flexibility
is key.
What if you could choose your future?
Hydrogen, biomethanol, freedom to decide.
The power of a multi-fuel future.
Because innovation isn't about taking sides, but about connecting ideas.
The future won't run on one perfect solution.
It will run on many, working together.
At Eco-Runner, we believe in combining possibilities.
Together, we drive change.
Together, we power the future of mobility.
Hello. Good evening, everyone. My name is Luc de Bruin. I am the Chief Engineer of Eco-Runner 16. So you just heard who we are as Eco-Runner and why the climate change is such a big motivation for us. And we will talk a lot about technology and solutions tonight. However, this problem is bigger than any single team or project. It's something we all experience and approach differently. But in the end, it affects all of us. So that's why, before we dive into the car itself, I'd like to get a sense of how you all in the audience feel about this topic. So that's why I've prepared some statements for you, for which I ask you to use the flashlight of your phone to show me if you agree or disagree. So please take out your phone and have your flashlight ready. Yeah, I see some flashlights already. So if you agree with a statement, please raise it up into the air. And if you disagree, please keep it down. And don't be afraid, there's no right or wrong answer, there's only your opinion, so no one will judge you here. Let's go to the first statement, and that is, the climate crisis is the biggest crisis of this generation. So if you agree, please raise the flashlight. Okay, I see the whole room lighting up. That's great to see. Yeah. Okay, you can put them down now. Yeah, thank you. We don't want your arm to get tired. It's good to see that so many of us are aware of the severity of this problem. And also the UN says that the climate change problem is the single biggest problem facing humanity today. And by meeting the goals of the Paris Agreement, we can save 1 million lives a year by 2050 through the reductions in air pollution alone. But now, I am curious what you say to the next statement. I am sufficiently contributing daily to solving this problem. So if you agree, please raise the flashlight. Okay, I see some lights, but... Yeah. Okay, thank you. You can put them down now. And now, to be honest, I think the opposite of what I saw with the last statement. And if I'm completely honest, I don't think I would have put my flashlight up in the air either. And that might seem very discouraging, but I can understand why. It can be very difficult to feel like you're actually contributing to solving the problem without completely uprooting your entire life. And that brings us to a broader question, not about our personal behavior, but about the solutions themselves. So that brings me to the next two statements, the first being, current measures to solve this crisis are lacking. So if you think that what we are currently doing is not sufficient, please raise your flashlight. Now I see a lot of flashlights again. So that means we all agree we must do more. So the next one is, proposed measures feel restrictive. There have been many extra measures proposed. Think of flying less or eating less meat, which is healthy for you, but not all of us want to do. And these measures can be seen as, can feel like they restrict our current lifestyle. So if you agree with that statement, please raise your flashlight. I see some lights hesitantly going up. It's getting more and more. Okay, I think it's around 50-50. But I think it's clear that many of us are aware how urgent and severe this problem is. And we know we must do more. However, we feel like the current solutions aren't completely suitable. And that means that not all gaps have been filled yet. There is still room and need for innovation. And that brings me to my final statement, which is there is not one single perfect solution for a sustainable future. So if you agree with that, please raise the flashlight. And now I see the whole room lighting up again. That's great to see, because this is exactly the message we want to spread here at Eco-Runner. We need to be flexible and think outside the box to solve this problem in a reliable way. And at Eco-Runner, we use our cars to promote and explore these new ideas in sustainable mobility. But how? How do we manage to design, build, and test a car all in a single academic year? Well, to do this, a structured planning and task distribution is vital. And at the start of the year, we divided ourselves into 5 departments who work together to finish our car. The first department is the management department, of which I am a part as well, together with Luna, Florine, and Jip. And our job is to enable everyone to perform at their best. We ensure a proper planning, we ensure integration between departments and continuity between Eco-Runner years. Then next we have our biggest department, the operations department. They arrange all the logistics in our year. Isabel and Jesse, they organized this event and all our others, such as the final test at the end of the year. We have Isabel and Meike, who manage all our external communications, so the socials, the newsletters, the website. We have Jasper, who formulates our technical story to the outside world. And we have Teun, and Boet, who contact new and current partners. And finally, we have Oscar and Floor, who make all the beautiful renders and graphics we see here tonight. They do a lot, as you can hear. Then we have 3 technical departments. The first being the body department, led by our chief body engineer, Wout. You'll meet him later. And the body department is responsible for the structure and aerodynamics of our car. So they make sure our car can handle all the loads and glides as efficiently through the air as possible. And Wout is joined by Mats and Selim as our aerodynamic engineers, and Olaf as our structures engineers. Then we have our smallest department, vehicle dynamics, led by Laurens, and he, together with Bjorn, is responsible for all the parts that make our car a car. So the wheels, the steering, the braking, and the suspension at the rear and the front. And lastly, our biggest engineering department, Powertrain, Electronics and Propulsion, or PEP for short. This is led by Job, and the PEP department is responsible for the entire drivetrain. And we have Koen and Jeppe as our propulsion engineers. They build the micro gas turbine, so are in charge of turning the fuel into kinetic rotational energy. And then Max and Thijs, our powertrain engineers, turn this kinetic energy into electricity and drive it to the motor. And then we have Alec and Olaf, our electronics engineers, who monitor everything and make sure all the subsystems communicate, so our whole system operates as efficiently and safely as we can. So what do? Well, as chief engineer, I am responsible for the overall technical success of our project. So I ensure that all technical disciplines work toward the same goal and fit together. So this means that I am involved in all the key design decisions, and I have to make sure that we meet all the performance and safety requirements we set at the start of the year. So now that we've covered the task distribution, we can move on to the planning. And an Eco-Runner year, it consists of 3 major parts: a design phase, a production phase, and a testing phase. And as we are here at the design presentation, I suggest we zoom into the design phase, as this is divided into 5 sub-parts: pre-design, conceptual design, preliminary design, detailed design, and final design. And it all starts in the pre-design phase in late August. And I remember our first day very well, back in August. We walked in and I was standing in our workshop and I looked around and I remember thinking, where on earth do we start? Because our team consists of many very bright minds. However, not one of us had any experience in designing or building a car or a micro gas turbine. So the task ahead was very daunting and seemed almost insurmountable. However, by going step by step, we made it work. And the first step was to get to know as much as we could about the car we were designing. Because before you actually start designing something, you have to know what you are designing. So this means we met a lot with our predecessors from Eco-Runner 15. We did a lot of research, met with professors and experts. Some of you are sitting in the room here today. And we set up requirements for our car. And after the pre-design phase, we went into the conceptual design. This is one big brainstorming session where you try to think of every possible way to meet the requirements you set. So at some point, even the idea to build the structure out of wood came up. And many of those ideas, including that one, are discarded very quickly. And at the end of the conceptual design phase, you are left with a few promising concepts per system. And these are worked out further in the preliminary design phase. And at the end of the preliminary design phase, you choose your final concept. That is the car you will be designing, and that is worked out in full detail in the detailed design phase. So you have to think of what bolts we use to attach the parts together. And then if I did my job right, we put everything together in the final design phase, and it should all fit. And then the design is finished. And well, we're standing here today, so I'm happy to say that we did a good job. And now that we know how we managed to design, build, and test a car in a single year, I'll let the people who actually designed everything in detail explain to you how it all works. Thank you.
Good evening, everyone. My name is Job de Steenhuizen-Pieters, and I'm this year's Chief Powertrain, Electronics and Propulsion. Or, as we like to call this department, the PEP department. And our department is tasked with designing and developing the car's engine. This engine is a microgas turbine, and it has three essential elements. First, there is propulsion. Propulsion uses thermodynamics in order to generate heat, and this results in combustion. Then, powertrain converts this heat into electrical energy, used to power our wheels. And third, electronics is there to manage and control the process, ensuring safe operation. And after 6 months of hard work by our PEP department, this is the microgas turbine we designed. A result we're proud of, because it's not every day that students get to build an engine. The design has 5 main components, and we will go through those step by step. But first, this achievement was made possible by the combined efforts of Jeppe, Koen, Alec, Max, Thijs, and Olaf. So, yes, definitely. Thank you. They definitely deserve applause. But it all starts at the compressor. Here, fresh air is sucked in and compressed. And this is important because air can hold more pressure then, and more energy. And from the compressor, the air flows towards our recuperator. This recuperator acts as a heat exchanger. This means that it can extract energy from hot exhaust gases, and it can use this energy to preheat the fresh incoming air from the compressor up to around 500 degrees Celsius. And this step is important because we use energy that otherwise would be lost towards the environment. So it increases the efficiency of our system. And from the recuperator, it flows to our combustion chamber, where the green fuels bioethanol or biomethanol are combusted to raise the air's temperature further, up to about 900 degrees Celsius. So this combustion chamber, it's producing hot and fast-flowing gases, which then reach our turbine. And you can see this turbine as a tiny windmill. But now the wind is replaced with these hot and fast-flowing gases. But just like the windmills you see on the side of the road, this turbine, this tiny windmill, is capable of transforming that airflow into rotational motion. And then we go to the fifth component, the generator. This generator can transform that rotational motion of the turbine into electricity. This generator generates electricity due to that rotational motion. Just like the dynamo on your old bike that produces light when it rotates. And that concludes the 5 main components of our microgas turbine. And now, I'd like to take you on a journey through the heart of the Eco-Runner 16. We will bring its engine with its 5 main components to life and follow the energy flow step by step. So imagine you take a step into that Eco-Runner 16 and you turn its starting key. Now, what's happening in the back of the car? Well, first, a battery is providing the system with electrical energy. So the battery is first powering the generator. But as you might know, this is strange, because normally the generator generates electricity, which then flows towards the battery. But at the starting procedure, it's not. Now our generator is functioning as a starter motor. It is fulfilling another role. This generator, this starter motor, will bring the system up to speed by rotating the compressor and allowing the processes inside the engine to start. And as this compressor rotates, an airflow is created through the main components of the microgas turbine. So air starts to flow through the combustion chamber, the recuperator, and the turbine. But as you can see, at this stage, the system is still cold. The recuperator is still cold. And therefore, the combustion chamber is struggling a bit at first. Now it's producing a smaller and yellow flame. However, this smaller flame is sufficient to bring some first heat into the system. So it will already create some hot and fast-flowing gases, which will reach the turbine. These hot and fast-flowing gases will start the turbine as well at this stage. And when this turbine and generator reach roughly 80,000 RPM, the generator can transition to its real purpose of producing electricity, rather than powering that compressor rotation. So from this point onwards, our battery is being charged, and the turbine is fully powering that compressor rotation. But now it's rotating at 80,000 RPM. But we're not there yet. It will continue to increase, up to about 150,000 RPM. As this turbine accelerates, the compressor also speeds up and will draw in more air. At the same time, the recuperator can now improve the efficiency, as there are hot exhaust gases to extract that energy from. This causes the combustion chamber to produce a strong and bright flame. And all these things combined bring that engine towards its most optimal operating point of around 150,000. And to put this large number into perspective, it spins around 30 times faster than your normal car engine pushed to its limit. During this entire startup sequence, electronics continuously monitors temperatures, pressures, and rotational speed. And they regulate things like fuel flow or generator torque to keep the system within its safe limits. This highlights how deeply electronics is embedded in our system and the crucial role they play in it. And now, hopefully, all of you have a better understanding of how this engine behaves. So it's time to focus on our key design challenge, which is to fit this entire microgas turbine into the limited space of our small city car, that Eco-Runner. And to reach this challenge, our PEP and the body department had many meetings over the past months. And to increase that compactness, we mounted the compressor, the generator, and the turbine all on one shaft. But this brings a new challenge to light. Because now we need to find a generator that can generate around 3 kilowatts of electricity, that can withstand a 900 degrees Celsius heat transfer from the turbine side, and that can rotate at a large number of 150,000 RPMs. And our challenges didn't stop there. We faced another challenge in the battery. But first, let me zoom out for a moment. So far, I've explained to you how we generate power. But generating power alone is not enough. That generated energy needs to be stored somewhere. And then it also needs to be used to drive the wheels of a car. These things together form what we call our powertrain. So this powertrain, it has three key systems. So first, that power generation system, which is the micro gas turbine that was just explained to you. Then we have the power storage system, which is why we need a battery. And third, we have the electric motor inside the wheel of the car that uses that stored energy to drive the wheels of our car. And with this broader view of our powertrain in mind, we can zoom in onto that specific design challenge of the battery. Back in the hydrogen era of Eco-Runner, our power system was designed around a lower power output. And when we realized that the power output of our micro gas turbine is higher, it forced us to rethink the battery design that Eco-Runner had been using for years. Because when you generate more power, it is as important to be able to store all that power effectively. Because if you don't, it's like you're buying a completely new interior for a house, but then trying to fit it all into that tiny student room. And in that case, a lot of potential is simply wasted. And that is why we doubled the battery capacity. This allows us to store more electrical energy and to fully utilize the power produced by our turbine. And at the same time, we place a strong focus on safety. Because now this battery is located on top of our micro gas turbine, operating in a harsh environment. As you have seen, this environment involves high temperatures, high rotational speeds, and significant vibrations due to that. And to cope with these conditions, we improved the structural integrity of the battery. So the design has been mechanically reinforced, making it safer and better able to withstand those thermal and mechanical loads inside our Eco-Runner 16. And that way, the battery becomes a safe and reliable component of our small city car. So, in short, our department has designed a compact and fuel-flexible power generation system, the micro gas turbine. And we made improvements on the battery design. But beyond how it works, a key question remains, which is why? Why are we building this fuel-flexible car? With that, we're going to the next part of the story, and I'd like to give the floor to Jip.
So, hi, it's great to have you all here tonight. And thanks, Joop, for this clear explanation about our engine, which is the key to our fuel-flexible system. My name is Jip Spaargaren, and I'm this year's operations manager. And tonight, I want to dive even further in the question why. Why fuel flexibility? That was the exact question I asked myself when I started my role in August. Since in the operations department, we are responsible for telling Eco-Runner's story and the importance of fuel flexibility to partners, press, on events, and through social media. But that would be hard if I myself had no idea what this concept really means. And we wanted to make our story more simple for you. Not only all this difficult stuff about our engine, because we know that the technical part of Eco-Runner is very impressive. However, the societal importance of our project is too. So at first, I needed to get the facts straight, and I wanted to truly believe in our story myself. I found it the most fun aspect of our role to investigate why we chose this concept and explore the relevance of this. To watch the news, read articles, and listen to podcasts to stay updated about the developments that are happening in the mobility transition today. We all know that the energy and mobility transitions are among of the most complex challenges we are facing. These transitions are not happening in a predictable world. They are happening in a world that is uncertain and constantly changing. This is clearly visible in policy making, for example. Until recently, the EU had planned to ban the sale of combustion engine cars by 2035 to reduce the use of fossil fuels. However, this proved too ambitious, and as a result, the plan was reconsidered and ultimately softened, and this was not necessarily decided in favor of reducing fossil fuels. This shows how plans can change in an uncertain transition. So, the challenge remains. How we will move from fossil fuels to greener solutions is still unclear. Therefore, you might be wondering the same thing as we did. What will our future look like? I believe that I can speak for all of us when I say that we recognize the importance of a more sustainable future. But at the same time, we will always want and need the freedom of mobility. The ability to move, to pursue a career, and to stay connected to the people around us. So, how do we ensure both? At Eco-Runner, we believe that there's not a single solution. It is not black or white thinking. Therefore, we design towards flexibility in a world that we believe will inevitably be multi-fuel. Let me explain why we believe this. In the mobility sector, a wide range of transport modes needs to be decarbonized. From heavy-duty transport to lightweight vehicles, and from long distances to shorter journeys. From personal road transport to sectors such as maritime and aviation. This diversity immediately calls for multiple solutions, and that is why an optimal mix of technologies and fuels is necessary. Rather than choosing one solution, we focus on a concept that connects multiple, a multi-fuel future. Fuel flexibility. We see it as an essential factor in the optimal mix, and I'm going to give you 3 main reasons why we believe this. Since we have seen that several economic and geopolitical, scalability and infrastructural complications have slowed down the transition to a sustainable mobility sector. First, economic and geopolitical resilience is strengthened by fuel flexibility. We have seen that less dependence on a single energy carrier means less vulnerability to sudden supply disruptions and price shocks. We've seen recently that prices of a fuel can spike overnight, for example, due to the war in Ukraine. According to research done by Boston Consulting Group, the key lesson to take from this event is that, and I quote, "Diversity is the key to energy security." If we want people to choose sustainable mobility, it has to be affordable. Fuel flexibility helps ensure this by allowing different fuels to compete on the market. Also, changes on policy making will have less of an impact when we are designed for flexibility. Second, scalability. Even though promising solutions already exist on the market, scaling these up is hard and takes time. We've seen with electrification, for example, that it is not efficient or practical for every transport mode. Solar-powered mobility is limited to very specific use cases. And sustainable fuels, such as green hydrogen, are not yet available or affordable everywhere. The greener solutions that exist now are not scalable now to fully replace fossil fuels. Therefore, we need solutions working in parallel, a multi-fuel future. Also, fuel flexibility reduces the pressure from any individual fuel. This helps prevent each individual fuel from becoming depleted or overloaded, which is helpful for resource scarcity, but also because large energy systems cannot be expanded overnight. This brings us to our last point, infrastructure. Infrastructure development is slow, expensive, and differs widely between regions. Fuel flexibility, where one day you tank bioethanol and the next day green hydrogen, means we don't have to wait until the entire infrastructure is designed for one specific fuel. Practical limits can arise even when an energy carrier itself is not scarce. This is already evident in practice, with electricity, for example. Grid congestion in countries such as the Netherlands clearly demonstrates that depending on a single energy carrier can quickly become a bottleneck rather than a solution. Further, a fuel-flexible car allows different countries to adopt different fuels in their infrastructure. Implementing sustainable biofuels in the current infrastructure is much easier and will help reduce the use of fossil fuels quicker. Fuel flexibility helps bridge a gap as infrastructure develops over time. So, these are the reasons why we believe that fuel flexibility is an essential factor in the optimal mix. And this is a story our department has been working on the last couple of months, and why we are building a fuel-flexible car. Now Wout and Lorenz are going to tell you how this fuel-flexible car is built. Thank you.
Hello everyone, I am Wout Tibbe and I'm this year's Chief Body Engineer.
And my name is Lawrence Koopman, and I am this year's Chief Vehicle Dynamics Engineer. The past few months, our departments have worked closely together to ensure that the innovation of the Eco-Runner can be implemented in a drivable car. The Vehicle Dynamics Department makes sure that the body is connected to the road and can be driven forward in a stable, safe, and efficient way. We design the systems that allow the driver to stay in control when forces from the road are transferred to the car. Forces such as bumps from the road or when we want to accelerate or decelerate. Ultimately, we are responsible for the design of the suspension, braking, and steering systems. And this year, we had a strong focus on designing low-weight components to improve the overall efficiency of the Eco-Runner 16. However, it is very important to find a balance between performance and safety of the car. Well, obviously, moving forward, that starts at the wheels. And for the Eco-Runner 16, we use energy-efficient tires that minimize drag with the road surface. And additionally, all 4 wheels are equipped with lightweight rims made from carbon fiber. And carbon fiber can significantly reduce what we at the Vehicle Dynamics Department call the unsprung masses.
So Lawrence, what are unsprung masses and why do they matter?
Well, you can think of the unsprung masses as the legs of the car, the parts such as the wheels or suspension. And they directly fuel the bumps from the road. And the lighter that these parts are, the quicker they can react to these bumps. And ultimately, there will be a better contact with the road surface, giving better grip, comfort, and driving stability to the car. So, carbon fiber is 40% lighter than its counterpart aluminium, whilst maintaining the same strong rigidity. So when we look at the rims, carbon fiber can significantly reduce these unsprung masses. And, well, if the unsprung masses are the legs of the car, then the suspension are like its muscles. And they connect the wheel to the body. And this suspension is designed to absorb shocks from the road, just like your own muscles in your legs absorb shocks and stabilize you when you run across rough ground. And this year, we designed a double wishbone suspension for the front and rear tires. The name double wishbone comes from the upper and lower triangular tubes, or wishbones, and they connect the wheel to the body. And to absorb the shocks, we use a spring and a damper. And in contrast to previous years, we moved these heavy components further to the inside of the chassis and connected to the wheel through a rocker arm. And this ultimately reduces the weight that needs to move up and down with each bump in the road. And another key feature of this suspension is its adjustability, because different drivers have different weights, and this impacts how the car behaves. So, by designing for adjustability, we can always tweak the suspension for the best performance for a variety of driving scenarios. So, the wheels and the suspension, they keep the car grounded. However, without a strong skeleton to hold all of these parts together, none of these subsystems would work as intended.
And that's where the body department comes in. So, let's talk about the structure of our car. As Lawrence mentioned, the structure of our car is its skeleton, the foundation everything depends on. Without it, there would be no standing car. And with it, the car becomes one solid mechanism. This year, we made an ambitious choice. We designed and built a space frame. A space frame is one of the most efficient structures for carrying complex loads, while keeping the weight as low as possible. On top of that, it can handle the heat generated by the engine really well, making it the perfect fit for our car. But choosing a structure is only the first part. To make sure it wouldn't only look good, but actually perform, we made use of the finite element method. In this animation you can see behind me, you can see how the forces travel through our structure. The red color indicates where the structure works the hardest. This is exactly where we strengthen it. While the blue color shows where we can remove material, saving weight. By every iteration, the structure became lighter, while maintaining its strength. In the end, we have designed a structure that is optimized for our specific load cases. But its role goes beyond that. It connects every single subsystem of our car into one coherent whole. So it's more than just a structure. But now it also needs to be controlled. Lawrence, do you have any suggestions?
Yes, thank you, Wout. I do have some suggestions. To control the car, we designed a steering and braking system. And for steering, we use a rack and pinion. And this gear system can withstand a lot of forces and has a favorable gear ratio, so the driver has smooth and precise steering control. And this year, we moved this whole steering system further to the front of the vehicle for better packaging efficiency. This means that there's more room in the interior of the car for all of these subsystems from the pet department. And when turning, the two front wheels naturally follow a different path. One wheel turns tighter than the other. And if this occurs, one wheel starts to slip. And we then lose energy, and this can even pose a safety hazard. So, during the design, it was vital to design the correct steering geometry to account for this difference. And to ensure that both front wheels smoothly turn when cornering at a variety of speeds. And when talking about speeds, well, we can probably all agree, driving fast, that's a lot of fun. But stopping safely, that's essential. So that's why the Eco-Runner 16 has a four-wheel braking system. This ensures that we can safely and reliably brake. And as part of the braking system, we also incorporated regenerative braking in the electric motor. This means that when we want to slow down, the motor works in reverse and we can recover energy. This energy is then fed back to the powertrain for later use. So from what I've just told you, we can confirm that the Eco-Runner 16 can drive efficiently, steer precisely, and also brake with confidence. But But if I look at the car right now, it's still incomplete. What are we missing?
Yeah, you're right, Lawrence. We are missing its skin, the body of the car. It's not only important for the looks of it, but also for its performance. Without it, a huge part of the efficiency of the Eco-Runner would be lost. But why is the shape of our car so important? Well, everything moving forward has to push the air out of the way, but this air pushes back. That resisting force is called drag, and it constantly slows the car down and wastes energy. Our job is to reduce that resistance as much as possible. And that's where aerodynamics comes in. Aerodynamics is all about controlling how air flows around our car. Smooth, undisturbed flow generates less resistance than turbulent flow. So we want the air to flow as smoothly as possible around our car, wasting the least amount of energy. Think of it like this. Imagine a fish swimming through smooth waters. And imagine it struggling in rough waves. The smoother the flow, the less effort it needs. Our design is based upon airfoils, which are the most efficient shapes to guide smooth airflow. You can see them here on the slide behind me. In the end, we have designed a car that's 3 times as efficient than a regular car daily on the road. But for the performance of our car, it isn't not only important what happens on the inside, but also what happens on the outside of the car. As the PEP department mentioned, the micro gas turbine generates a lot of heat. And if we don't manage that heat properly, we don't only hurt the performance, but also risk damaging the body. That's why we integrated a heat management system within the car. This system isolates the inner panels with isolating materials and keeps the temperature stable, even during peak performances. So by making very well considered and smart choices in both the space frame and the outer body of our car, we push the absolute limit in efficiency, while maintaining its strength and safety.
So, when we bring all of these elements together, a steering and suspension system, a space frame structure and aerodynamic shell, and of course the micro gas turbine at its center, we get the foundation of the Eco-Runner 16. A car that is lightweight, strong, and fuel flexible. Months of design, countless iterations, and one final result. Finally, as the Eco-Runner Team Delft, we are proud to present to you the Eco-Runner 16.
Wow, what an incredible design. Combining all of our strengths together is what really brought us this far. Because the design would not be complete without the body, engine, and mechanical parts fitting perfectly with each other. And, as importantly, the operations and management team behind it. Without that full integration, we would simply not be standing here tonight. And I am extremely proud of every single team member, who all have been working really hard for the past months. That we are together setting the first steps towards this fuel-flexible future makes me feel really proud. As the team manager, part of my role is to support the team and connect members and make sure everyone performs at their best. And what makes me really proud is not to see what we achieve technically, but also the team and personal growth I've seen throughout the year. Because at the beginning of our year, most of the team members didn't know each other yet. And joining such an ambitious project and big group of students is easier said than done. But during our onboarding process in August, I realized that for this team, that wouldn't be as hard. I noticed how easily we laugh together and how each team member is always willing to help each other. And that is really the foundation that allowed us to come this far. Besides working really hard inside the Dream Hall, we shared many experiences together outside of the Dream Hall. We visited external events, companies, and fairs together. We even traveled all the way to Barcelona for a congress about the future of mobility. We went on team weekends, played a lot of football, and ended many weeks with drinks together. All in all, we became one big group of friends, and that spirit truly defines this team. But in the end of the day, we could not do it all ourselves. Forming strong collaborations throughout the year is what really makes the Eco-16 possible. So I would like to give a special thanks to everyone who provided support to us, and especially all of our partners. Both the long-standing partners who provided trust, support, and expertise for many years. They believed in us during our hydrogen era, and they still believe in us with our new Eco-Runner focus. And as well, our new partners, who brought new perspectives, new energy, and as well a lot of trust and support. So, on behalf of the entire team, thank you so much for supporting us and believing in us. You've made the Eco-16 possible. I am looking forward to the rest of the year, where we will bring this design into a real-life car. And at the end of May, we will, in the end, reveal this car to all of you during our car review. You are all warmly invited to be there. For now, I think there is one question remaining. And I would like to ask you again, turn on your flashlight if you agree with this last statement. So if you are all ready, I will show this last statement. The last statement is, I believe that the future of mobility will be multi-fuel. Wow. It is incredible to see how so many of you are convinced as well. And with this last confirmation, I would like to close the evening. I want to thank you all for coming, because seeing this room filled brings us a lot of motivation and energy. And now I would like to invite all my team members to the stage so that you can give them a warm applause. And then I would like to give you to invite you to the foyer to have a drink with us. Thank you so much. Heel. Leuk. Ja.